Okay, so now I'm going to try to explain to you how perspective works. Now, any sort of confusion that may come from my explanation here might be solved by my module, and it might be solved by reading the textbook, How to Draw by Scott Robertson. Everything that I teach you in all of my classes will be in either Scott Robertson, How to Draw, Scott Robertson, How to Render, or Betty Edwards, Drawing on the Right Side of the Brain. If there are any questions that come from that, and I can't answer them, they're usually in there, with the exception of one or two things which I can usually point you to. Anyway, perspective as the thing gets closer to you, it has the illusion of getting bigger. As it gets further away, it has the illusion of getting smaller. In 3D and real life meat space, it's a given. It's a sort of thing that we take for granted and don't think about, and that's why it took so many thousands of years for people to finally get how linear perspective works. So the question becomes, how do we represent that in a two-dimensional space? We start with a horizon line. Now the horizon line isn't necessarily what you think it is. The horizon line is not necessarily the horizon of what you're looking at. It's the eye level of the viewer. So if the horizon line, if the viewer looks up, the horizon line moves with them. If the viewer looks down, the horizon line moves with them. The vanishing point usually falls somewhere on the horizon line, and the vanishing point is where things get so small that they completely disappear. Now, the number of vanishing points determines the type of perspective drawing that we're using here. 1 point means one vanishing point means 1 point perspective. 2 vanishing points is 2 point perspective. 3 and so on and so forth up until 6. 1, 2, 3, and 5 are the ones that you'll be using ever for the most part. 4 point perspective, there's no point. You might as well just use 5 point at that point in time. It looks better anyway, and no one can look at it and discern the difference. The human eye actually sees in 5 point perspective because it has 5 vanishing points: one in front, one above, one below, one left and right, and that causes a fisheye effect. So when you look at something and you see a straight line, you aren't actually seeing a straight line. You're seeing a curved line that your brain is correcting for. So I'm going to start by talking about 2 point perspective. Generally, I'm going to do just about everything in this class in 2 point perspective because it's easiest to explain that way. Got 1 point right here. Got 1 point right here. 2 vanishing points. Now, say I have a dot right here. Now, that's not a vanishing point. That's just a dot that we're going to use. So, the easiest explanation that I have for any amount of perspective, the one rule that applies to all forms of perspective drawing, is that all points in your image relate to all vanishing points. So if it's 1 point perspective, this point only talks to the one vanishing point. If it's 2 point, it talks to both. So I'm going to take it and I'll make a line. Sound effects included. Now, a line is 2 points, 1 point and 2 point, and they both need to interact with those vanishing points. So from here to there, from here to there. That's this point interacting with both vanishing points. From here to there. From here to there. Now the whole line is interacting with both vanishing points. Now we have this sort of like Will Smith Independence Day sort of thing going on where we have this cube that expands well past our horizon. We don't really necessarily want that. So I'm just going to draw cubes here because drawing cubes is just good practice. So at this point, you get the most creative control you're going to have for the most part when it comes to drawing things in perspective. You get to choose how thick it's going to be. So here's one right here. I'm going to put a line right here. And since this line is attached to this line, it's already interacting with that vanishing point. And the line that would be created from this line would be covered up by the front of the cube. You don't draw it. So you can just assume that it's being affected by the other vanishing point. But you do have to draw one from this vanishing point to that dot because that dot isn't interacting with every vanishing point. Like that. Now, I'm going to do another one right here. And that defines how thick the cube is going to be again, right there. So, from here to that vanishing point, there we go. We got a nice cube just hovering in the sky above us. Now, since this is above the horizon line, it is taller than us. Because you got to remember, the horizon line is the eye level of the observer. So if you're looking up, it's above the horizon line. If you're looking down, it's below the horizon line. So now, I'm going to draw another cube, but I'm going to just start with the line this time. Right here. On the horizon line. Now, I'm going to draw another cube below the horizon line. Okay, so go with 3 cubes. And this is a really good illustration as to how perspective works, or how the horizon line of perspective works. Everything above the horizon line is taller than you. You can't see the top of it, but you can see the bottom of it. Everything below the horizon line is shorter than you. You can't see the bottom of it, but you can see the top of it. If something's on the horizon line, it shares the same height as you. You can't see the top or the bottom of it. Now, the same thing works left and right, too. If we had 4-point perspective right now, or 5-point, we had a line down the middle. It's like right here, or whatever. Like that. Everything on the left of the line, you wouldn't really see the right side of it. Everything on the right side of the line, you wouldn't be able to see the left side of it. That's just the nature of how it works. So when you have 5-point perspective, I'm just going to sort of like, I'm going to kind of try to explain this. There's a vanishing point here in the front. There's one at the top, one at the bottom, one at the right, one at the left. That's 5-point perspective. So every point interacts with every vanishing point, which means that as this line is being affected by that vanishing point, it's being pulled on by that vanishing point too. So there's a curvature to it like that. You get kind of a fisheye effect. The same thing happens to all of it. It's trying to, and this line right here is trying to work with both vanishing points. It will be curved like that. It's really hard to describe 5-point perspective. I think you really just ought to look online and try to get a good eye for it. Now, one way to think about it is to think about it as an imaginary grid that you put on there. Here are my axes right here, right? That's my vanishing points, 1, 2, 3, 4, 5. So you can draw them like this. Think about having a grid. And there's no mistake here. The closer you get to your vanishing points, the more distortion you're going to see. And I'll demonstrate that in a minute here. This is a really sloppy sort of drawing of it, but you can just imagine this sort of grid over something and think of that in terms of your vanishing points and 5-point perspective, and 5-point becomes relatively easy, but you have to get more intuitive with it. Anyway, one more thing to keep in mind when it comes to working with vanishing points is the closer you get to the vanishing point, the more distortion you're going to get. Like, look how drastic these lines have to get in order to interact with that vanishing point there. Then look how not drastic that line has to be. So you get a distortion from it. So if you got a cube, it looks like it's being sucked into a black hole, kind of. Um, The answer to this question right here, or the answer to that whole problem right there, is to realize that if you're watching Netflix or if you're looking at a photograph or reading a magazine, the vanishing points are never in the image. They're never there. The actual image that you're seeing is more like this. That's the picture plane you're usually looking at. The vanishing points are usually way off the screen. So, here's an exercise I'd like for you to try real quick. I would like for you to put your thumbs out directly in front of your face, right? And then, say, here's your head. Here's your shoulders. Your thumbs are directly out in front of your face. You're looking at them. There's your thumbs. Now, I want you to keep your eyes facing forward. Keep your eyes facing forward, but extend your arms out this way slowly until your thumbs are no longer in your peripheral vision. And then move them forward a little bit, just a little tiny bit, so that they're back into your peripheral vision. Those are your actual real life vanishing points that you personally have. They're way off in your peripheral vision. You never pay attention to them. Another interesting thing here, it's not really even related to the lesson, but your peripheral vision is colorblind. You don't see anything out there because the color receptors in your eyes are cone-shaped and your eyes are spherical. So because of that, the shape of the light waves can't reach the edges of your eyes, so your peripheral vision is colorblind. But since the rods can, you still see blacks and whites and darks and lights. So you can find your own vanishing points. And if you do the same thing up and down too. You can find a vanishing point up and a vanishing point down and a vanishing point directly in front of your face. And those are your personal vanishing points. Let's see. What else do I have about perspective right now? Well, not much. And if you would like some further elaboration on that, I would recommend either asking me personally or going onto the Scott Robertson How to Draw book. It will have all the answers.